Okay, new topic today, and this is going to be 9A. Now there's these first two, you don't have to write stuff down, just observe kind of how we're going to line it up, and then we're going to learn the shortcuts ways for it so we can solve the problems more efficiently, okay? The first question says there are three types of sandwiches. You have turkey, ham, and roast beef. Three types of sides, and those sides could be coleslaw, soup, and fries. How many meals can we create? Well, you got turkey, you got ham, you got roast beef for your sandwiches, and for your sides you have coleslaw, soup, and fries. Okay. Well, you can get a turkey sandwich with coleslaw. You can get a turkey sandwich with soup. You can get a turkey sandwich with fries. Okay. Now, if you got your ham sandwich, you get the same coleslaw, soup, and fries. And if you got your roast beef sandwich, you could get coleslaw, soup, and fries. And that's all the possibilities. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, there's an easy way to figure this out. Okay, easier than listing all of it. You got three options of sandwiches, and you have three options of your sides, so really you can just multiply the possibilities, and that's 9. And that's known as the counting principle, where you just take your number of choices from each category and multiply them together. It's the counting principle. Okay, now there's another one. It says Chad, Martha, Thomas, and Enrique are in a 4-person race. How many orders of finish are possible first through fourth? You don't need to write this down, just watch. So let's say Chad wins, okay? Well, Martha could get second, Thomas third, Enrique fourth. Now, Chad, Martha, then you can flip these last two, Enrique and Thomas. Okay, that's 2 right there, okay? Now, Chad could still win, and then let's say Thomas can get second, and then Martha, Enrique, Chad, Thomas, Enrique, Martha, okay? Now, Chad can win, and then maybe Enrique gets second, then Thomas, Martha, Chad, Enrique, Martha, Thomas. That, I think, covers the scenarios if Chad wins, okay? So Chad wins. That's going to be 6 possibilities of finish when Chad's the winner. Now, if Martha wins, there's going to be 6. I don't need to list them out. It'll work out the same way as it did over there. Thomas could win. That'd be 6. And Enrique could win. That'd be 6. So 6, 6, 6, 6 makes 24. So that 24 is the answer, but there's got to be a quicker way to do it than that, okay? Because if let's say instead of only 4 people, I give you 10 people, well, that's going to take forever, okay? Now this here is what's called the factorial principle. F-A-C-T-O-R-A-L. Factorial rule is what it's called. We had 4 people in this race. I put a 4, and then you put a symbol that you haven't seen in mathematics before. You put an exclamation point. Now that's known as a factorial. What you do with a factorial is you simply take 4 times every integer down to 1. 4 times 3 times 2 times 1. And 4 times 3 times 2 times 1 is 24, because that would be 12 times 2 is 24 times 1 is 24. That does work. But that only works if you're looking for the complete order of finish, where you care about first, third, and fourth and all that. Okay? Now we're going to go over some examples. Okay, example 1. We need to evaluate 5 factorial. You don't call it 5 exclamation point. It's an exclamation point, but it's called factorial. To evaluate that, you just take 5 times every integer down to 1. Okay? And if you multiply that, there's 120. So if you had 5 people in a race, there'd be 120 complete orders of finish possible. Really pretty easy. Okay? Evaluate 10 factorial. So that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. By the way, if you have one of these calculators, you have to have one of these. If you don't, you have to multiply all the way down, which you can do. But you'd hit 10, then you hit the PRB key, and then you drag the compass over to the exclamation point, and then that gives you what it is, okay? So again, 10, PRB, drag your right arrow over to the exclamation point, and that's the answer. So if you had 10 people in a race, there would be 3,628,800 orders of finish possible, okay? Obviously, nobody's going to list all that, but. Okay, example 3 factorial. This is an easy one. 3 times 2 times 1 is 6, okay? So that's how you evaluate factorials. Now, the next part isn't really an example. It's something I want to kind of talk about. Chad, Martha, Thomas, and Enrique are in a 4-person race. How many first and second place finishes are possible? Now, we don't care about third and fourth, okay? So when I list them, you're going to notice how I only list 2 people because I just care about first, second, okay? So Chad, Martha, Chad, Thomas, Chad, Enrique. So that's 3. Now let's say Martha wins, well then Chad can come in second. Notice how I don't care about third and fourth here. I drop third and fourth from the whole evaluation process. Okay. Enrique, Chad, Enrique, Thomas, Enrique, Martha. And then Thomas can win. Martha, Thomas, Enrique, Thomas, Chad. So that's all the possible first, second, so that comes out to 12. Now, there is a possible way you can do that quicker, okay? And here's what it's called. It's known as a permutation, okay? You don't use a factorial because factorial finds all the places. We just want 2 of the places. What you do is you set up this P here, and you had 4 racers to start with, but you just want first and second place. Now, you're going to circle that, okay? Because you need those people placed. What you don't need placed are the last 2. There's 2 places that you need, the first 2, then minus these, and then there's 2 places that you don't care about, okay? So what you're going to do is you're going to make a ratio. You're going to put your 4 factorial on top, but you need to drop the last 2 places, okay? This right here. So I divide them by 2 factorial. So here's how you do that. You're going to go 4 times 3 times 2, but you're going to stop at 2 factorial. Put the factorial sign, underline it, and that 2 factorial that's already there, those can cancel. And then 4 times 3 is 12. So it's a quicker way to get my 12. Okay, that's called a permutation. Okay. Now, example 4. You got to evaluate 9p3. Here's how that's supposed to be written, okay? I couldn't do it on the Google Drive. It's the 9 and the 3 are down here as subscript numbers. Okay, so first off, if you have 9 places and you need first, second, third, then the last 6 places, 9 minus 3 is 6, you need to drop those orders at the end. Now, you're going to circle the 3 because we need those people placed. So what I do is I take 9 factorial and I divide by 6 factorial. I circle the 3. When I circle it, that means I'm not going to put it as part of my math. Okay, I've always taught my students, okay, on permutations, okay, you need the first, second, third. So circle them because we're going to keep those out. We don't want them on the bottom. We don't want to cross those out. We want to cross out the last 6 places. So 9 times 8 times 7 times 6. And then we're able to cross out the final 6 places. So 9 times 8 times 7 is really the answer to the problem. So 504. Okay, example 5. You got P, and then it goes 8 and 5. So you care about the first 5 places. You drop the final 3 places. So we keep the final 5. So we don't put that, or here, we need to put this 3 here right there, okay? So 8 times 7 times 6 times 5. Now when I get to the final 3 places, I stop because then those can be canceled out. Okay. So 8 times 7 times 6 times 5 times 4, 6,720. Possible rankings of 1st through 5th. 1st, 2nd, 3rd, 4th, 5th. Okay, example 6. You got P and then you got 11, 4. So there'd be, I need to drop the final 7 places. So I keep the 4, drop the final 7. So I don't want to put the 4 on the bottom. Remember, you want to drop the final 7 places. You don't want to count those. So what you do is you put them on the bottom so they get canceled out. Sevens cancel. And I just take 11 times 10 times 9 times 8. I don't really need to divide ever. 7,920. Now we're going to go into some story problems, okay? They're not hard, really, okay? It says, a license plate is made up of 4 letters and 3 digits. How many different license plates are possible to create? Now keep in mind you have 26 letters to pick from and 10 digits. Okay, this is the counting principle. So we need letters. We need 20. We have 26 to pick from. Okay. Now we have 26 to pick from, but we need 4 of them, and you can repeat them. So what you do is you take your 26 to the 4th power. Okay. And we also have digits to pick from. Now this is like that this is like the sandwiches and sides problem, like the coleslaw, the roast beef, but we didn't use exponents because we only picked 1 of them. Now we're picking 4 letters, okay, 26 to the 4th, and we have 10 digits. So if I picked 1 digit, I'd have 10 to pick from, but when I need to pick 3, I raise it to the 3rd power, okay? So counting principle is just multiplying, okay? So you don't use any exclamation points, no P's, any of that stuff. So you take 26 raised to the power of 4 times 10 to the power of 3. And that's literally the answer. This is why everybody has their own license plate, because there's always so many you can pick from, okay? Okay, example 8. There are 4 people in a race. How many complete orders of finish are possible? Now, finding complete orders of finish is just a factorial rule, okay? You have 4, okay? And you just take 5 times 3, 4 times 3 times 2 times 1, and that's 24, okay? 24 complete orders of finish. That's how that gets labeled, okay? See right here it says license. This would be license plates. Okay, but it wants complete orders of finish. A complete orders of finish, that means every order of finish we count, so it's 4 exclamation point. Okay, and then on this assignment, the other type of problem we have is there are 12 countries in the medal round of Olympic hockey. How many ways are possible for countries to finish 1st, 2nd, and 3rd? So our answer is orders, but not complete orders, just 1st, 2nd, 3rd. That's what we're looking for. So because you're not looking for complete orders, you only want the first 3 orders. You want to drop all orders after the first 3. You use the permutation, the P, okay? So you have 12, and you need to place 3 people. So that means you drop the final 9 places. So that's a ratio. So 12 factorial divided by 9. I'm circling the 3 so I remember not to put it in the expression. So it's 12 times 11 times 10 times 9, and then we're able to drop the last 9 because there's that 9 on the bottom. So it's just 12 times 11 times 10. So 1,320. So those are kind of the three types of word problems you'll see. You'll see the counting principle. You're just counting how many license plates. Use the multiplication. There's complete orders of finish. That's the factorial. Then there's orders, but not complete orders, just first, second, third. Okay, in that instance, you use the permutation. Okay, example 10. A quiz bowl team must have a freshman, a sophomore, a junior, and a senior. There are 61 freshmen, 50 sophomores, 60 juniors, 45 seniors in a school. How many teams can be created? So we want to know how many teams. That's the counting principle. Okay. So we need a freshman, 61 of those. We're only picking one of them, so I don't raise to a power. Times, well, you need a sophomore. There's 50 of those. No power because you only pick one of them. Then juniors 60, and then seniors 45. Okay, and then you just multiply 61 times 50 times 60 times 45. That's a lot of teams possible to create. Not how many teams will be created, just how many are possible. 8,235,000. Okay, example 11. There are 9 people running the mile. How many ways can the competitors finish the race? Okay. How many orders? I didn't word that very good. How many orders can the competitors finish the race? So we're looking for orders and we're looking for complete orders. Like they don't say first and second. Just assume it's complete orders if they don't specify placing. Okay, complete orders. So that's the factorial, and it's just 9. Okay. So 9 times, you could go all the way down to 1. Remember, if you have this kind of calculator, you can go 9, hit the PRB symbol, drag that compass over to the exclamation, and there you have it, 362,880. Okay, I think we already had that permutation come up before. Okay, then the last example I have, example number 12. There are 50 golfers at the state tournament. How many ways can the competitors finish first, second, and third? Okay, so again, I want orders, but I don't want all 50 orders. I want just first, second, third. So because I don't want the complete orders, I need to use the permutation. Okay, so we have 50. We want the first three places, but I need to drop the final 47 places from the expression. Okay. We want the 3, we don't want the 47. So I start with 50 factorial, and then I just put that 47 on the bottom because that'll be able to cross out. So 50 times 49 times 48 times 47, and then we're able to drop the final 47 places. So 50 times 49 times 48. Nope, not that. Okay, 117,600.